Hey guys, welcome back to another video. In this video, we're going to be looking at different graphs of polynomial functions, and we're going to start to analyze some different things on those graphs. Now, this is going to be a part one of a two-part series over analyzing these polynomial functions and their graphs. So check back tomorrow for part two of this video. So let's take a look at this. Today, we're concerned with graphing. And then we're going to be looking for the x-intercept, and the points where we have local maximums and local minimums. All right, and we're going to explain what that is, but I think the best way to explain it is to show you. So let's go ahead and take number one here and type it into Desmos so that we can see what this looks like. All right, and of course Desmos is a graphing calculator. It'll give us nice, pretty graphs, what we're looking at. Okay, so let's type this in. We're gonna do 4x cubed minus 12x squared. Also, don't put in the f of x equals just because Desmos doesn't like it and doesn't really understand it. Well, all we have to do is just put in the function itself. All right, so we type it in, and this is what we get. Let's zoom out a little bit. All right, so this is our function. Now, we're going to have, of course, our zeros, or the place where it crosses the x-axis, at these points right here. So we can see that our zeros for this function are -1, 1.5, and 2.5. Okay, so we can go back to our, we can go back over here and say that our x-intercepts are, what was it, -1, 0? Was it 1.5 and 2.5? Am I remembering that properly? -1, 1.5, and 2.5. So we can write this as a fraction. 1.5 is the same thing as 3 halves, 0. And then 2.5 is 5 halves, 0. All right, so those are our x-intercepts. Those are our x-intercepts. So now let's look at our local maximums. Our local maximums are maximum points in a general area. So if we look back at this graph here, a maximum would be like a point where in that general area, it's the maximum point. We can see right in this area, we have a maximum point right in here. We have a maximum point right in there. So we can say that this point right here is a maximum. So a local maximum. So it may not be the maximum point on the graph because, I mean, these points over here are obviously higher than this point right here, but it's a local maximum, which means in this local area, right in this area, this is a maximum point. So if we were climbing this little hill or whatever here, sure, there's a higher mountain over here. You know, over here it's higher, but in this general area, in this local area, this right here is the maximum. So I think this is the only local maximum we have. We're looking for, again, those little hilltops for local maximums, and you can zoom way out and see that I think that's the only place where we're going to have like a peak, and then it just keeps going up forever over here, so we don't have a maximum. It just kind of is unbounded. So we can see our maximum is -0., and these I guess we'll just be okay with estimating. So -0.04 and 15.02. Okay, -0.04. And was it 15 0.02 for our y. I think that was right. So that was our local maximum. Now we want to look at our local minimums, and sometimes there can be more than one. In this case, we only have one local minimum right down here, and it's the exact same principle. In this general area, in this local area, we have a local minimum right here. So 2.04, negative 3.02. Oops, that's not what I meant to do. Okay, what was it? 2.04, negative 3.02. 2.04, negative 3.02. So that's our minimum. So we got a minimum here, local min. We got a local max up here. And then we also have all of our x-intercepts, or we can call them our zeros. Our zeros are over here. All right. Okay, let's look at one more. We won't write it all out this time, but just to give you just another look at a different function. Let's look at number 2 here on Desmos. So let's type this in. So we're going to have 2x to the 4th plus 5x cubed minus 21x squared minus 10x. And let's zoom out so we can see. Oh, this one is interesting. Very interesting function we got here. Okay, so first of all, zeros, places where it crosses the x-axis. Looks like we have one here over here at negative 4.5, negative 0.43. Looks like the origin 0, 0 is a 0, and 2.5. All right, and then local maximums. We've got one local maximum right in here at negative 0.22, 1.13. And then notice that we have two local minimums here. We have a minimum right in here, and then we also have a minimum way down here. So we have two minimums, two local minimums right here and right here, and then one local maximum right in here. And then there is no other maximum. It goes up forever over here. So these functions are all going to be unbounded. So their end behavior is going to go forever in one direction. So anyway, so yeah, we have one maximum, two local minimums. One local maximum, two local minimums. But you get the idea. But yeah, that's all there is to finding zeros and then finding local mins and local maxes. Y'all check back tomorrow. I'm going to post another video, and we're going to look at some more the things and ideas concerning these polynomial functions, that ways we can analyze the graph to get some information out of them. Anyway, guys, y'all have a good day, and I'll see you next time.